Simple tutorials. Thank you. Welcome everyone. As you all know, we're here for finding complex circuits using star to data conversion, and data to star conversion. Okay, let's see how complex the circuit is. We said you should find the equivalent resistance and the current that flows through the circuit.
If this is the first time watching my video, I would like to welcome you and still more give you some morale that you're really doing well. And I want to appreciate and thank you for watching my video. Emperor loves you. Emperor loves you. Okay. Now we're solving a complex circuit. Now let's look at this complex circuit for now. It's 100 volts, 24 ohms, 20 ohms, 10 ohms, 60 ohms, 30 ohms, 13 ohms. And how do we solve a question like this, and what do they expect us to do? Remember, you have gotten the knowledge on delta and what and star. If you don't know anything about delta and star now, I will advise you to watch my previous video and get the hint on it, because this will just be like a magic if you are looking at it for the first time. Okay, now let's look at this now. First thing I would like to ask you here, you watching this video right now. What do you observe in this circuit? Do you see any star there? Can you picture a star there? Can you? Okay, let's look at this. What? Can you picture a star here? Okay, look at this. I have this now. Okay. Remember we draw star like this, exactly like this. So look at this. Can you see any star here? Yes. You can see it, not? There's one star here. There's another star here. Is that not? Exactly. Good. Okay. So with this star here and star here, let us now solve a question like this. Some will say, oh, this solving do not pay any money. Okay, what about the social medias and all these things? People waste their time. Do they also pay them any money? No. We are doing this just to increase our knowledge, and again, in your field, you'll be able to master it anywhere. Because of in electrical or any subject you can do, what you need more is your reasoning. How can you reason? In a question like this, without what we need to do, we are increasing our reasoning. Okay, like this now, we have a question like this. How do we get it? Now, I can make use of either 24 ohms, 30 ohms, or 20 ohms. Or I can make use of 10 ohms, 60 ohms, or 20 ohms. Which one should we go with? I trust you would like to go with this first. Okay, let me go with this first. I have this now, just like the way I draw this. Put this 10 ohm here. Put this 60 ohm here. Put 20 ohms here. Remember what we did, I took it like this. Then we have this. Then I want to solve it the way we solve star to dot delta. So I'm going to look for this is going to be my RA, RB, and RC. But bear with me, my R1 is equals to RA, RB, plus RC, plus RB, RC, plus RC, RA, divided by R. Remember the R1 is here, so it's supposed to what? RB. Okay, so we join this. RB is what? 10 times 60 plus RC 60 times 20 plus RA. That's going to be what? 20 times 10 divided by RB. What is my RB? That's going to be what? 60. Okay, what do I have? 10 times 60. 1 times 6 is what? 6. 0, that's 600. 6 times 2, that's going to be 12. 0, 0 is 200. Plus 2 times 1, that's what? 2. Plus 0, 0, that's 200. Okay, let's go like this. 600 plus 1, that is 18. 18 plus 200. That's going to be 2000. Am I correct? Divided by what? 60. Let's verify that. 188. Why for R2? We're going to be having, we're going to be having the sum of these was 2000 divided by R3 is represented as RC, R2 is represented as RC. We're going to have 2000 divided by 20, and this will give us 100 ohms. Very correct. And we have R3 to be always to this. That's going to be 2000 divided by 10. And that will give us 200 ohms. 200 ohms. Let me continue with here. Okay. With that 200 ohms now, can I withdraw my starting data? Remember, we're having something exactly like this. Narration like this. Then we have this like this. Draw this down. Okay. From this now, we can now make use of. We can now input our R1, R2, R3. Remember, here is going to be R3. Here is R1. Here is what? R2. Now R2 here is what? R2 here is 100 ohms. R3 here is what? 200 ohms. And R1 here is what? Is going to give us, okay, 200 divided by 6. 200 divided by 6. 2 here, 3. 2 here, 100. 3 here, 1. 3 here, 3. 33.3, okay. Give us 33.33, okay. So, to write this very well, we have 200 ohms, okay. Don't mind my handwriting, let's continue. Okay, from here now, you know what we did here was that it was like this, we made it straight. Now, from this point to that, it was like this. It was like this before, we made it straight, so I'm going to bend it back. So I'm going to return this circuit back. So while we're doing that circuit back, I'm going to redraw it here. Exactly at this point here. We have that to be like this. Okay. Yes. Okay. Yes. Now I want to take it back like this. So if I take it back like that, here we'll be having R1. Here we'll be having R2. And here we'll be having R3. Your own diagram will be more better than mine. Okay. And we'll join this together. Okay. Now, taking this to that side now, we have here to be R1, here R2, here R3. And our R1 is what? Is 33.3 ohms. Isn't that? R2 is going to be what? Okay, R3 rather. R3 is going to be what? 200 ohms. And R1 will be 100 ohms. Okay. From here now, this place is what? Is 24 ohms. Here is what? Is 30 ohms. And this top side is what? Is 30 ohms. And here is plus minus 100 volts. Now let's solve. Now in resistors, this 2 is in what? Is in parallel. This 2 is in what? Is in parallel. So we're going to solve this 2 in parallel. So parallel resistors. We'll talk about the parallel resistors now. Parallel resistors. Okay, for parallel resistors we have 24 parallel to what? 33.3 ohms. They are parallel to each other. That's going to be 24 times 33.3 divided by 24 plus 33.3. And that will give us a punch a calculator. We have the answer. This also is in what? Is in parallel. We have that to be 30 parallel 200. 30 times 200 divided by 30 plus 200. That will give us what? Solve it. I'll give you 1 minute for that. 1 minute, solve it now. Okay. So now, at this point here, you have 13.948 ohms, if you solve it rightly. And here you have 26, approximately 26 ohms. Okay. Now, I have to withdraw this circuit now. I want to withdraw that circuit now. So withdraw this circuit now. Withdraw the circuit. We're going to have exactly this. So these two are combined now to have 13.98948. I can call it 13.95 ohms. It is going to be 14 ohms, but I want to just leave it like this. 14 ohms. Let's call this 14 ohms. Let's call this 14 ohms. Approximately 14 ohms. Okay. Now like this. This side too will become what? 26 ohms. Then we're left to do this here. And this will be, oh no, 100 ohms. Okay. Join it together. And these are the 13 ohms. These two are in series, so I'll add them together. 14 plus 26 will give us what? So series resistors. You have 14 plus 26. And that will give us 14 plus 26, 20 plus 10 will give us 30. 30 plus 10 will give us 40 ohms. Okay? So I'll withdraw the circuit again. Withdraw. And we have exactly. Okay. Then only one resistance, because these two are joined together. So I only have one. To call this 40 ohms. And this will be 100 ohms. Okay. Now let me clean this. So these two are in parallel. So I'm going to solve them in parallel. So I have parallel resistance again. Parallel resistance. That's going to be what? 40 times 100 divided by 40 plus 100. So that is going to be 40 times 100. And 4,000 divided by 140. 4,000 divided by 140. This will cancel this. Okay. 400 divided by 14. So this will give us 400 divided by 14 will give us 28.5 ohms. And this is approximately 29 ohms. Okay. Approximately 29 ohms. And now we're going to solve this now. While solving this now, we're going to have something like exactly like all this now will be equivalent to what? To withdraw the circuit to this 29 ohms. So we have added this together, it's going to plus. So all this now will become one resistance again. So I withdraw the circuit and we have exactly this, it's only one resistance left. And that's going to be what? 29 ohm. And here it's going to be what? 13 ohms as we have at this point here from the beginning of the circuit. Okay, now we're going to draw this 100 volts. There are current flowing here is I. Okay, this and this is what? They are in what? Are they in parallel? No, they're in series. Okay, so since they're in series, we're going to find our total resistance. Our total resistance is going to be what? 13 plus what? 29. And that's going to give us 42 ohms. And that is approximately 40 ohms. That's approximately what? 40 ohms. So we're going to solve this continuation. Continuation. This 40 ohms now, you are asked to look for this current I that flows through it. So the current I and the current in the figure. So from Ohm's law, I is equals to what? V over what? R. Our voltage here is what? Is 100. So 100 divided by the total resistance here is what? It is 40. So 100 divided by 40 is going to give us what? 2.5 amp. So we have our total resistance to be this, and 2.5 is this. I will make use of delta conversion from start to delta conversion to solve this, and that is all using series and resistance cycle. Yeah. Like and subscribe to my video right now and share it to your friends. If it's helpful to you, share with them, get in touch with them, and God bless you as you bless their life with my content. Please make sure that you like and subscribe. What am I saying? Like and subscribe. Do that now. Do that now. What I Thank you. God bless you. Oh my God. It's simple, isn't it? It is simple, isn't it? Isn't simple.